Hello, good day. I'm going to show you for our video how we could use Microsoft Excel in order to apply matrix operations. So we're going to deal with matrix or work with matrices. And then we have some functions in Excel that could actually help us do that. And we will also, I'm going to show you as well how we could also use a very useful web application or a website that would help us to uh, work on matrices and for all other related mathematical problems. Okay, so I'm going to begin with matrix operations. So most of us are already familiar with matrices. Okay, so it's an array of elements. It could be multidimensional, right? Array of elements. So uh, let's try to have an example for matrix addition. So I'm going to define a matrix. Let's just say that we have our matrix over here. So this is matrix A. Let me just have the elements of this matrix. So this is just random numbers that I'm going to use here. Say this is our matrix. All right. So we have our matrix A. So next we have our matrix B. So for matrix B, let's say we have the following given. So let's say 6, 1, 0, 2, 3, 9, 7. Okay, so two matrices. So what about if we are going to perform now matrix addition? So matrix addition is basically we do it like this. So we, for example, in this particular example, we're going to perform matrix addition A plus B. So what would be the result of this? So basically what we're going to do is to select the matrix. That would be matrix 1 or matrix A plus the other matrix. And then you will have the answer. So it's as easy as that. Matrix addition here has been performed for matrix A and matrix B. Okay? So the same is true for matrix subtraction. So A minus B. Alright? So to perform A minus B, so we select the first matrix. This is the first matrix minus the second matrix. And then press enter and you will have the result. So this will now be matrix addition, matrix subtraction. Now what about matrix multiplication? So for matrix multiplication, we actually have a function for that. So let me just have here the function for that, and that's M matrix multiplication. All right. So first, I'm going to select the first array, mmult. All right. And then I press on the comma, and then selecting the second array. And now I will have the product of the matrix. Product of matrix A and B. Now what about for the inverse? So once again, I'll just type in the formula here. It's mmult. Okay. So that it will not be evaluated. So that's M multiply. And then I have selected this matrix. Okay. Let me just copy this one. So, right. So we copy this one, including its value. Okay, just copy this one. Right. So this is the formula that I used. Okay. So E4G6, that's actually this one, matrix A and matrix B. In Excel, you could actually name a part of the Excel cells. You could just name it here. So for example, matrix A, and then here this will be matrix B. So you can also do that. So for example here, instead of highlighting the cells, you could simply call on matrix A, and you could also call on matrix. Let's see if this has been defined correctly. Okay. So let's try that again. Matrix A, matrix B. All right. So there. So make sure it's been defined correctly. Okay. It's defined correctly. And when you call on it in Excel, it will automatically be computed for you. The same way here, we can now use matrix A, right? And matrix B for this particular uh, example as well. Just gonna place in matrix A and then matrix B. All right. Okay, so that's the tools that we could use for Excel. So that's matrix multiplication. Let's now move over to the inverse. So let's say, for example, we are going to consider the inverse of A, inverse of matrix A. Now, the formula for this is the uh, Excel formula M inverse. So in this case, we're going to call the array. We could simply select the array, or we could call the name of the cells for this array. In that case, that's matrix A. Okay? And now this is now our inverse. All right. So it's easy, right? Okay. So that's the inverse. Now, what about for the determinant? Say, for example, we're going to get the determinant of matrix B. All right. So determinant of matrix B. So to do that, we have the the Excel formula mdeterm. mdeterm. And we're going to select our matrix B, and it will automatically compute for the value of the determinant. So once again, let me just copy over the formula that we have over here so that you could have the formulas that we have used as well here. mdeterm is what we have been using for matrix B. Okay? All right. So it's just as easy as that, no? It's just as easy as that. We simply did or selected the array, perform the addition or subtraction. We have some Excel functions that would help us determine the product, the inverse, and the determinant. Now, what about the transpose? So for the transpose of our matrix, this is what we're going to do. So transpose of matrix A, let's have it here. So the function for this is simply transpose. Okay, and we're going to call on our matrix A, and there we have it. Transpose of matrix A. All right, so that's for the Excel functions. Now for the adjoint function, okay, the adjoint is actually the transpose of the matrix of cofactors. Okay, so there is no direct Excel function for this, but I'm going to show you as well another web application that's very useful, can be accessible by anyone, doesn't need for you to register for accessing this website, and you could also perform matrix computations. And what this website is Wolfram-Alpha. So I'm going to show you here. All right, so this is Wolfram-Alpha. So when you search in the website itself, the name is wolframalpha.com. Okay, wolframalpha.com. So here you could input any mathematical expression, including matrix computations, expressions in calculus, even algebra, and it would solve that equation for you. So that's the beauty of Wolfram-Alpha. So I'm going to show you how it could be done here. So for example, we have two options for the input. We could have natural language or math input. For natural language, you could say, for example, a joint matrix. So let's say a joint of, and this is how it defines the matrix. So it defines it by element. This is row 1, row 2, row 3, and row 4. So for example, we're going to define our matrix. We have a 3 by 3 matrix, right? So it will look like this. So the first elements, if we're going to go over our Excel, let me just transfer to the Excel. All right. Okay. So Excel here is 2, 3, 5, 9, 12, 6, and 3, 4, 9. Say, for example, we're going to use these inputs. So 2, 3, 5, 9, 12, 6, and 3, 4, 9. So let us go over to Wolfram-Alpha and let us input those values that we have. All right. So this would be 2, 3, 5. All right. And we have 9, 12, and 6. And we have 3, 4, and 9. Okay. So it automatically computes the adjoint matrix for this. And we have the result 2, 9, 3, 3, 12, 4, and 5, 6, 9. Now the beauty of this is you could also compute for the determinant. It would automatically solve for the determinant, negative 21. Right? And it could also solve for the inverse. So you basically just type in inverse. So it would solve for the inverse like this. Okay, so it has the inverse. And if you want to input it in math mode, so you just select the matrix here, and it would you can then type in the terms or the elements of the matrix. It's very easy, right? So really very easy for you to use. And aside from, say, for example, the functions that we have or the matrix operations that we have already tried for this particular example, you can also use this to solve for determinants, to solve for eigenvalues, eigenvectors, and all other things. All right. So even on the free version, you can already do a lot of things. Okay. You can already do a lot of things. You could input mathematical expressions and it would automatically solve for you. Okay? So really very helpful for you guys. Now, if you go over to our Excel sheet over here, once again, we just switch over to Excel. All right. I'm going to show you now how we are going to use two types of numerical analysis to solve for the roots of an equation. So what we're going to do now is we're going to use Excel and we're going to compare our results with Wolfram-Alpha and as well as the calculators. By the way, if you're going to use your calculators, it's also very easy for you to perform computations or operations involving matrices. So I have shown here how you could do that using your Casio and your Canon calculator. So first off, let us begin with your Casio calculator. So to perform matrix operations, it's really very simple. So you go to mode, you go to the sixth option here, so that's matrix. We define our matrix. Say for example, matrix A here is 2, 3, 5, and then 9, 12, and 6. And then we have 3, 4, and 9. Okay? So I'm going to press AC here, and I'm going to define another matrix. So I press Shift, and then matrix over here. I'm going to define matrix B. So I could set the dimensions first of matrix B, or I could immediately determine the data. Since I haven't defined the dimensions of matrix B, I can press on 1 and I would then define the dimension of matrix B as a 3 by 3 matrix. So after that, I will input the element 681. I have 4, 2, 0, and 3, 9, 17. All right. Okay, so how do I perform matrix operation? So shift matrix, I'm going to call on matrix A. For example, I'm going to add a matrix, so I'm going to do it like this, call on matrix B, and of course we have the result. So if you're going to compare with the result that we have, so it's 8, 11, 6, 13, 4, 6, 8, 6, 13, and 26. So it coincides, it matches with the results that we have on exam. Okay? So really very easy to do that. And if you explore the matrix submenu here, you could also see a lot of other uh, operations that you could do for matrices. So you could use this to solve for determinants, pressing on 7. And you could also use this to solve for the transpose of the matrix. Matrix multiplication can easily be done as well by simply using the multiply key. Alright, so matrix A, matrix B, and we will have the results. It's already matrix multiplication. See, as you see here, we have the same results with the matrix that we have in Excel for the matrix multiplication. Matrix inverse can also be computed by simply calling on the matrix and raising it to -1. So this is now our matrix, and as you can see here, inverse matrix of A is the same with what we have on our Excel. All right, so that's how we use our calculator. Determinant. So let's go over to the matrix function, determinant, and we're going to call on our matrix B. So we have here -310 for the determinant. All right. So this is for the Casio calculator. Now let's go over to our Canon calculator. Here the Canon calculator has a variety of functions as well, and perhaps it has even more functions than the Casio calculator. So we go over to mode and we go to matrix, that's 7. So we can even define 4 matrices or matrix here in the Canon calculator, the F789SGA. So for the matrices that we could define, you actually could define multiple types of dimensions. You can even define a 4x4 matrix here. Alright? So the 3x3 matrix, if you just scroll down here, you can see it here in the second submenu. So let's try to input our matrix A, 8, 11, 6. We have 13, 14, 6, 6, 13, and 26. I mean, sorry, this is already A plus B, right? So let me just do that again. Sorry, guys. So 2, 3, and 5. So 9, we have 12, and 6, and 3, 4, and 9. All right, so this is matrix A, as you can see there. Okay, so I could go over to apps. I could also define, right? I could also define my other matrix, dim. Dimensions of matrix B could be defined as well like this, 6, 8, and then 1. We have 4, 2, 0, 3, 9, and 17. Okay? So I pressed on CA, I called on the matrices, so matrix A plus, we have matrix B, and you can perform the operation. Right? Very easy to do so. Okay, and if you want to, of course, subtract, you simply just change the sign there to subtract. All right. If you want to multiply, then it's like this. Okay. All right. Now, if you're going to get the inverse, so we call on the matrix, say for example, matrix A, and we get the inverse by simply raising it to -1. So get there the inverse. Now, if you go over to apps again, if you notice, I clicked on this submenu and I could also see here, all right? I could also see here the other different functions that we could do. So we have the determinant, transpose, identity matrix, adjoint, okay, and then the inverse of the matrix. So really a lot of functions that we could do here, okay? For example, we define the adjoint. Earlier, we used Wolfram-Alpha. But here, using your calculator, you could also do so. This is the Canon F789 SGA calculator. Very, very useful calculator.